All right, let's look at a second example from our simple harmonic motion unit. Again, I recommend pausing the video here, taking a look at the question, and trying to figure it out on your own before looking at my solution. So here, while performing a lab, a student suspends a 200-gram mass. Mass is 200 grams. Is equal to 0.200 kilograms on a spring. When it is pushed, it oscillates with a frequency of 3.00 hertz. And we are just trying to figure out what the spring constant is. So right away here, first thing I would do is I would take this frequency and we're going to change it into a period instead. So remember, frequency and period are inversely related. So the period is going to be equal to 1 over the frequency. 1 over 3.00 hertz is our frequency. So this will be 0.3333. Let's give ourselves lots of decimals, seconds. The next thing that we can do here is, since we're talking about a spring on a mass and we're talking about a period, we're going to jump right into this equation here where our period is equal to 2 pi multiplied by the square root of mass divided by k. So look at that, we've got an equation with our spring constant in it. We know what the period is, we know what the mass is. 2 pi here is just a constant, so all we have to do is isolate for k. This can be a little bit tricky just because it is inside the square root, but if we're careful, we should have no trouble. So first thing I'm going to do here, I will divide both sides by 2 pi, cancel those out. We have t over 2 pi is equal to the square root of m over k. We can take the square, we'll square both sides. Get rid of the square root, so we have t squared over 4 pi squared, I'm just distributing the exponent, is equal to m over k. We can multiply the k up, and we end up with k is equal to, and we'll multiply this 4 pi squared up as well, so m times 4 pi squared divided by t squared. This is a nice little trick. Anytime you have two terms that are equal to each other, you can kind of just swap the position of these ones if you want to get something up to the top, if you're trying to isolate the k. So anyways, k here is going to be equal to that 0.200 kilograms multiplied by 4 pi squared divided by t squared. T we said was 0.33333 seconds squared. And if we plug this into our calculator, we should work this out to be that our spring constant is 71.1 newtons per meter. Keep in mind our number of significant digits here. We've got 3 digits there, 3 digits here, so we want 3 in our final answer as well.